This is problem number 7, where we have to insert a bunch of numbers into an AVL tree. This is directly from the Trees Lab. Let's go ahead and get started. First number is just going to be our root, and that just has balance factor 0, so that is done. 20 is smaller than 60, so it goes to the left. Balance factor of 20 in this case would be 0, and the balance factor of 60 is 1. So no problems there. Oops. All right. Let's insert number 40. So 40 is smaller than 60, but it is bigger than 20, so it goes right here. And if we check the balance factors, balance factor of 40 is 0. Balance factor of 20 is -1. Balance factor of 60 is +2. So we have a problem here. So we know that we're going to need to do some rotations to fix this. And this is our left-right case. So first thing, we're going to do a left rotation this way to get us to the left-left case, and then we're going to do a right rotation. So let's go ahead and do that. So the first thing we're going to do is we're going to make a rotation here. Actually, might be able to actually just rotate it. Never mind. That's what it's supposed to do, though. Alright. And notice this is still a valid BST. Okay, we're not done yet, though, because we need to do one more rotation, which is to bring 40 up as the root and bring the 60 down. All right, let's see what our next number is. 70. All right, so 70 is bigger than 40. 70 is also bigger than 60, so it goes right here. Balance factor is 0. Balance factor of 1. Also balance factor of -1. So no problems there. All right, let's go ahead and insert number 10. 10 is smaller than 40. It's also smaller than 20. So it goes right there. Not too much of a challenge there because balance factor here is 0. Balance factor here is 1. And then 2 minus 2. Okay, now this is 0. Still no problems. All right, let's insert 30. 30 is smaller than 40, but it's bigger than 20. Balance factor is 0. For 20, the balance factor is now also 0. And for 40, balance factor is still 0. 2 minus 2. All right, next number, 50. 50 is bigger than 40, but it's smaller than 60. So it's going to go right here. Balance factor for 50 is 0. Balance factor for 60 is now also 0. And 40's balance factor is still 0. 2 minus 2. All right. Insert number 80. 80 is bigger than 40, bigger than 60, and bigger than 70. So it goes all the way down here at the right. Balance factor is 0. 0. Balance factor of 70 is now 0 minus 1, so -1. 60's is 1 minus 2, so also -1. 40's is now 2 minus 3, also -1. Still no problems because it's all -1s, 0s, or +1s. All right, 65. 65 is bigger than 40, bigger than 60, but it's smaller than 70, so it's going to go right here. Let's update our balance factors. 65's balance factor is 0. 70's balance factor is now 0. 60's balance factor is still 1 minus 2, so -1. 40's balance factor is 2 minus 1, 2, 3. Yeah, so still -1. No problems. 75 is bigger than 40, bigger than 60, bigger than 70. It's smaller than 80, though, so it's going to go right down here. All right, balance factor of that is 0. 80's balance factor is now +1. 70's balance factor is 1 minus 2 is Uh-oh, did I erase that? -1. And let's see, 60's balance factor is 1 minus 1, 2, 3. So that is -2. So this is our problem node. So we're going to look at the, basically the two nodes that come before our problem node in this kind of chain as we were working our way up from the insertion point. So 60 is going to be a node that we're interested in, so is 70, and so is 80. Notice the signs here match, -2 and -1. They're both negative numbers. So we know that this is a single rotation case. It's kind of the linked list case. I like to just go ahead and grab this whole subtree out here. We're going to do some rotations, and then we're going to stick it right back in. So let's go ahead and do those rotations. I also like to box these, because these could be big, huge trees down here. In this case, it's just a single node. It looks kind of wasteful, but... And let's label them A, B, C, and D. So what we're going to do to rotate this when we're fixing it is we're going to bring the 70 up as the root. The 60 and the 80 are going to come down here. Notice these are the three nodes I underlined. Those are the nodes of interest. And then it's kind of trivial where 80's children go, because 80's, they just go right under 80. And 60's left child still stays as tree A. But then 70's left child becomes 60's right child. So this is A, B, C, and D here. I think maybe I didn't leave myself enough room, so I'll just redraw the new tree up here. Notice that A is 50, B is 65, C is 75, and then we didn't have a D. D subtree was null. Okay, so now we're done with that. Perfectly balanced. Oh, I suppose I didn't update the balance factors. Okay, we'll do that next time. Let's insert number 45. 45 is bigger than 40, smaller than 70. It is smaller than 60, and it's also smaller than 50. It's going to go all the way down here. Balance factor time. Balance factor is 0. 1 minus 0 is 1. Let's draw a positive 1, just to be extra clear. 60's balance factor is 2 minus 1, which is also positive 1. 70's balance factor is 1, 2, 3 minus 1, 2, which is positive 1. And then 40's balance factor is now 1, 2 minus 1, 2, 3, 4. So 2 minus 4 is -2. So this is our problem node, and remember, we're going to look at the ones that came before it in the chain. The two that came before it in the chain. So the signs are opposite. One's negative, one's positive here. -2 versus +1. So we know this is a double rotation case. So let's go ahead and draw our boxes of what a tree A is. So this is going to be tree A. Okay. Now let's see what tree B is. Okay, so tree B is going to be, oops, there we go. Tree B is going to be these two nodes down here. This is B. Tree C is going to be the right child of 60 right here. And tree D is 70's right child here. This is tree D. So what we're going to have here is we're going to first rotate such that, and remember, these are 3 nodes of interest, are 40. Now we're going to have, oops, there we go. Now we're going to have 60 here and 70 there after we do our first rotation. And let's just label that this would be A, so that's the entire subtree I labeled A. 60 is going to have B, and then 60's right child, so this is still something that's bigger than 60. but it's smaller than 70 because it's in 70's left subtree in the original. So it's going to be C and then D down here. And then this is still not done, so we still have to do one more rotation to fix this, which is that 40 is going to come down here. 60 is going to be up here. 70 is going to come down here. And let's see where the subtrees go. So after we do that rotation, 40 is going to have its children be A and B. 70 is going to have C and D. All right, let's put the original subtrees back in now. D is this right here. Let's see if I can grab it. Ah. All right. Nice. Let's clean this up a little bit. This is the right child. Okay, and then tree C, let's just draw these in, actually. It's going to be just the node 65. Tree B was 50, and then 45. Tree A is a doozy. Let's see if I can squeeze this in. It was 20, and then 10, 30. Alright, so this is our new tree. Let's erase the old one now. And clean things up a little bit. Alright, that was 45. 35, bigger than 60? I'm sorry, 35 is smaller than 60. It's smaller than 40. It is bigger than 20, though, and it is bigger than 30, so it'll be down here. Now I'm running out of room. Let's give myself a little more space here. Okay, it was 50, then 45. Bear with me. It's going to make it a lot easier to follow. Everything is nice and neat. Alright, now let's do balance factors. 0, this is 0 minus 1, so negative 1. This is 1 minus 2, also negative 1. 40s is 1, 2, 3 minus 1, 2. That's positive 1. 60s is 1, 2, 3, 4 minus 1, 2, 3. 4 minus 3 is positive 1. Okay, nothing to fix there. Let's go ahead to the next one. 25. So 25, smaller than 60, smaller than 40, bigger than 20, but smaller than 30. So it's going to go down right down here. Balance factor is 0. Balance factor of 30 becomes 0, because 1 minus 1. 20 becomes 1 minus 2. Okay, so it stays negative 1. 40 becomes 1, 2, 3, minus 1, 2, positive 1. 60 also doesn't change. It's 1, 2, 3, 4, minus 1, 2, 3. Yeah. So we are done. So this is our final tree.